The Athletic.
The Race F1 Tech Show, brought to you by Aramco.
We explain how 3D printing is revolutionising Formula One, take a look at McLaren's latest innovation, and tackle Pirelli's wet tyre troubles. F1 is back, and so is the Race F1 Tech Show, brought to you by Aramco. I'm Edd Straw, and I'm joined as always by the inimitable Gary Anderson, who has designed, dismantled and reassembled more racing cars than most of us will ever see in our lifetime. So hello Gary, obviously we're recording this after a dramatic rain hit Zandvoort weekend, so given your history with such chaotic races, you must have enjoyed watching that one.
I did enjoy watching it, yes. It was one of those sort of things where it was one of those, I'd love to have sent in some comments to the Racing Live section, but to be honest, by the time you'd have got them in and got them up, it would have been too late because things were changing so fast. But yeah, it was good. I sort of struggled a little bit at the beginning to see why people stayed out on the slicks because you're going to lose so much time. If you imagine, I talk about 10% from intermediates to dry tires, it's about a 10% lap time difference. So you're talking 8, 9, 10 seconds a lap difference in a damp condition on intermediates to dries, and that's just 3 laps. You've covered a pit stop. So in those conditions, you're far better to just get on with it. But I mean, it's where you are on the track as well, where the pit entrance is relative to where you are as to whether you can take immediate advantage or whether you have to lose a lap and take the advantage then or a disadvantage as such. So yeah. Things were happening very quickly. He needed to make quick decisions, and that's what I enjoyed about my time in Formula One.
It was one of those difficult ones, wasn't it? Whereby if you stopped on lap 1 or 2, you were fine. But if you went to lap 3, that was the point where you had to keep going because otherwise you were chasing time you'd already lost. So that's always a great one when it's so precipitous, if you like, in terms of when you make your stop. But anyway, we're going to start off with the normal thing of you having a free choice of what you'd like to talk about in the first part of the podcast. So what's grabbed your attention in the world of F1 this week?
Well, there is 2 things. One is the McLaren rear wing, and the second one is tyres. McLaren rear wing, the detail of their rear flap to the end plate, I thought was quite a novel idea. Detaching that is quite a nice thing to do as far as reducing the drag is concerned, because what happens with that corner of the wing is you've got low pressure underneath the wing surface on the underside of the wing. You got high pressure on top of the wing surface, and you got sort of more or less ambient pressure on the outside of the wing end plate, and all 3 of those join up somewhere, and that sets up quite a large vortice, which as I say, you can see in the wet, spiraling off the back corner of the wing, and because that vortice is behind the car. It's a bit like a parachute. You're dragging it along behind you. It helps the wing work a bit better because it's accelerating that air out underneath the bottom of the wing in that detail. But it's a pretty inefficient way of making the wing work better. So it's a bit like if you look at the aeroplanes now, instead of the wing ending up just sort of the end of a wing on an aeroplane, now they've turned it up or turned it down, and that's to sort of dissipate the lift, so that you don't get that vortice off the wing tip of an aeroplane, because that vortice, again, for a plane is drag. You're just tugging it along. So by turning the wing up, you don't lose load, or you don't lose lift from the wing. You end up dissipating the pressure differential across the surfaces, so it gets to the pressure differential where the wing actually ends at is more or less equal. So there's no vortice set up there. So again, in the racing car, it's the same sort of deal, but it's about chasing as much downforce as you can on a racing car with the limited regulations, the limited width of the rear wing. And it's nice to see somebody doing something a bit different, detaching that end of the flap from the end plate, allowing the top and bottom flow of the wing to connect up together without really being influenced by the flow on the outside of the end plate. And it's quite nice. I'd love to see now what they get to Monza with, because it's obviously Monza's a much more important circuit for straight line speed. Zandvoort's a bit more, you want the downforce on the car. You just need to be practical about the levels of drag at Zandvoort. It's not Monaco, it's not Hungary, but it's knocking on the door. So interesting to see if they've really clicked onto something, and if their Monza rear wing actually exaggerates that sort of emphasis.
Yeah, and we know that the Monza rear wing, they're in a bit of a race against time to produce, so it can have the latest ideas incorporated in it. It's not an off-the-shelf, low downforce one, but it was interesting because that rear wing didn't actually qualify and race because of the weather conditions, because it was wet in qualifying, and also because Oscar Piastri had broken one of them rather carelessly on Friday. So I'm sure we'll see that in action, even if there's not a version at Monza. I'm sure we'll see it in Singapore.
Well, as I say, you will lose a bit of downforce with it, but the efficiency level would be different. So I don't blame them for putting on as much downforce as possible when we saw the conditions on Saturday for qualifying. And that obviously helps, but at some point in time you've got to sort of work out the efficiency you want to try and run the whole car at, because it's the combination of the whole car that adds up to the efficiency of the car. So yeah, you've got to make your decisions on the hoof with those sort of things, but if you have it available to you, well, you have it available.
And it's great as well because it's one of those really visually obvious ones. You did a piece on the race website headlined McLaren's eye-catching rear wing detail. So if you search for that and Gary's name, that should come up. But it's just a really straightforward, easy thing to see. Obviously, you've annotated some images as well, but anyone, no matter how technical or not, would notice that one. And those are the changes that are always interesting, because it's far easier to explain a concept when it's something big rather than something that's just a slightly different angle or slightly different shape.
Yes, it is. I mean, you get so many different, little camber change on something, a little bit of a different radius or whatever. It's difficult to sort of really know how big a change that would be, just the numbers. But that as you say, it's a visual thing, and it's quite nice to see different things coming out. And I suppose being reasonably successful. Obviously, as you say, they didn't run it in the extreme wet conditions. And that's probably because they wanted to save them as well, because it's very easy to lose one or two by indiscretion, I suppose you might call it. But yeah, it's something different might lead some other teams in a different direction. There might be a scrabble now for Monza to make something, because you can modify things. You can cut and shut. It's not the end of the world. And teams are learning how to do that now with the budget cap as well, how to get on and get the jigsaw out and make a few modifications here and there rather than having to design it completely from new.
Yeah, it's amazing when you see the cars up close, the amount of cutting and shutting that you now see, and patched up much more than they used to be before the cost cap. But that's a conversation probably for another day. You also mentioned tyres. So what's on your mind regarding the black and round bits?
Well, we get a lot of conversation about tyres. I mean, obviously we got three, at a race meeting that Pirelli bring along 3 compounds of dry weather tyre. One thing I'd like to say about them initially is that I don't think the compounds are far enough apart. From my point of view, I think you could very easily spread those compounds a bit more and still end up with 3 good tyres. But then we get to the wet situation, and obviously that's a bit of a drama right now. We've got a lot of talk about visibility, and there's a big difference from visibility and aquaplaning. And what we saw in Zandvoort really was the visibility was bad, but the aquaplaning was even worse. And we saw that down at turn 1, especially people going straight on. So it's one of those sort of things the visibility will always be a bit of a problem, and it'll take a lot of time to find solutions to it, which the FIA are looking for now. But as far as the tyres are concerned and aquaplaning, we have a situation where you've got an open opportunity to do whatever you want. We know now from what we experienced that the wet tyre has a very, very limited window of operation. I mean, it's really got to be hurtling it down. And when it's doing that, it's the visibility is so bad that it's just, not possible to drive the car. So we're stuck in a situation where the intermediate is a decent tyre, and it can be used when the track is quite wet, So in my book, I would sort of look at making an intermediate tyre that has got a little bit more land to sea area. And you're only talking about, a small percentage reduction. So there's basically more rubber on the ground, a little bit less groove, more rubber on the ground. So it would go, we talk about a 10% difference between whenever you can get, if you're on the intermediates and you're 10% slower than a slick time, it's time to think about getting slicks on the car. And those first laps are always a little bit risky. So it would be nice to have an intermediate tyre that might leave you not 10%, but 6 or 7% of a slower than a slick time, and be able to run to that point, because when you do put the slicks on, then it wouldn't be so risky. So that's one thing. Then just taking exactly the same tread pattern, because obviously it works. tread pattern, the stability, and then making a more of a sea area. In other words, opening the grooves up a bit more, less land area, but just the same profile, because it obviously works. And the big thing I'd do with those two tyres is to make them a larger diameter than the slick tyres. At the minute, there's a small amount of difference between the intermediates and the dries, and a little bit more of a difference between the wets and the dries. But it's still small. It's still millimeters. Now, aquaplaning is when the bottom of the car gets on the ground. There's two ways. One, the bottom of the car sits on the ground and the wheels are off the ground, basically. Or the tyres just can't cope with the water that's on the track, and they aquaplane. So you could either just make the tyres quite a bit bigger. And I'm talking here, for the wet tyres, have a front tyre that's 15 millimeters bigger, maybe even 20 millimeters bigger in diameter, and a rear tyre that's proportional to that. So you do actually lift the car up in the air, because it's a one tyre supplier. Everybody has the same problems, and if that's the way it's going to be, that's the way it's going to be. And again, with intermediates, sort of half and half. So you basically cater for when you're going to have to use them. So you have a bigger diameter intermediate than the slick. You have a bigger diameter wet tyre again. Tread pattern the same as the intermediate, but with more sand, more sea area, less land area, so you can pump more water through it. And I think you've got a very simple solution. You can have slightly different compounds. If the wet tyre is moving too much because of the amount of open area you have, then it can be a stiffer compound. It's not a problem. That can all be sorted out later on in life. But just, let's not just talk about these problems. Let's do something about them. And as I say, the two big problems are, one, aquaplane, and the driver's a passenger. He's that's it. He's going for a ride somewhere. So that would sort of fix a lot of the aquaplaning problems. And two, the vision. Well, the vision is just you want to be as risky as you can. I mean, if you don't, the throttle works both ways, as they say. So you can go slower, but at the end of the day, they are trying to fix something up to help the vision. It'll take time, but there is something going on to try and make it better. As I say, it will take time, but I'd go for the tyres first.
Yeah, and F1 has to make some big decisions on this, because if you ask Pirelli about it, they know they need to make their full wets a bit better, but they also say the main question is that because there's that spray guard project, which we've talked about a few times before on this podcast, they need to know whether that's going to progress, and therefore they need more extreme wet tyres that can deal with a lot of surface water, or whether you go more towards something like what you've talked about there. You were suggesting having two versions of the intermediates, if you like, but they've even talked about having a super intermediate, as they've called it, which is just basically a single intermediate-ish wet spec of tyre that is designed to run in the conditions where you get green flag running in F1.
Yeah, the problem with that is, we've got that now, I think, in reality. And what I'm saying is it's a little bit near the mark when it comes to deciding to put slicks on. You can get away with it, but it's just that bit close. And we'll see some drivers will go out and crash just because, they have to take that opportunity to put them on that little bit earlier. So if that window was a little bit smaller, I think you would help the situation with your decision about putting on dry tyres. You still have to put on dry tyres, but it wouldn't be a 10% difference. It'd be a 6 or 7% difference between the dry weather time. So that means the track would have to be that little bit. You could run the intermediates that little bit further, and the dry weather tyre wouldn't. There wouldn't be such a big step to it. And again, it's the same sort of thing with it from wets to intermediates. At the minute, the wets themselves are a good 10% slower than intermediates when you change them. The big problem with the wets is that if you get a couple of dry patches, that the tread power and the tread design is so unstable. It's just little blocks of rubber, little squares of rubber, as opposed to the intermediate design, which all connects up. These little blocks of rubber, yes, they allow lots of water out of there, but they're just so unstable. It's like riding a motocross bike on the road. The thing just walks across the road on the rubber. It just doesn't. You can't load up all that rubber at the same time. So each bit of rubber just grips and then lets go and lets go. And that's why they overheat and just destroy themselves. So I think it needs a tread philosophy change. The intermediate, to me, is a good tread philosophy because it does connect up. It doesn't have independent parts. There is grooves in it for sure, but you can take a path through there and you've got rubber all the way. So, the load does transfer from one bit of the tire to the other. So I think it's very solvable very quickly. But again, I think the diameter of the wheel or the tyre is a very important thing in controlling the wet as well and stopping the aquaplaning.
And Pirelli definitely have an alternative tread pattern that's an evolution of the current intermediate that's for that super intermediate project. So they've done some work on this. So yeah, I think it's all going to depend on what happens with the spray guards, but you can't wait around forever for that to happen because that's a project that may have no end, as we've discussed before. So yeah, the wet tyres are an endless talking point. We had plenty of drivers complaining about the full wets after the race at Zandvoort. Well, our interview later with Matt Jones from Stratasys is all about 3D printing, additive manufacturing. So Gary, I wanted to ask you a bit about your experience of 3D printing technology in F1. It had just started to creep in to F1 when Jordan started. So when did you first start using it? I doubt if that technology was the first thing you were ordering when you were thumbing through catalogues, filling up an industrial unit that had nothing in it to build an F1 car in.
No, it wasn't as high on our priority list as you might have thought. However, we did have a close relationship with a Rover sort of base at Gaydon, and they had some rapid prototype machines that they use for obviously doing whenever they're building their cars, for doing duct work and heating vents and all that sort of stuff. And we did very quickly start using them, probably 92, 93. We would start using them quite a bit to sort of build up some fairly rough prototype parts just to try and sort of optimize the positioning of everything. But it was fairly basic. And we did some wind tunnel parts as well. Once we got to know it a bit better, we sort of modelled some front wing end plates and some brake ducts and that for the wind tunnel model. And then we bought into the fact that we needed to move on ourselves. And luckily a company came in called 3D, and they supplied us with a machine. And it was like our pride and joy. We polished it every day, really. We had this 3D printing machine. You could watch these things appear out of this resin and you think, oh, look at that, it's good, isn't it? It was always something nice to take visitors around and show them through the screen of it, because it's always exciting. But now it's become such a big thing. I still use a company near Cranfield here that's got a massive 3D printing operation. They've got machines coming out of their ears, massive machines at millions of dollars per unit, and they do a lot of work for a lot of Formula One teams. They make structural front wings. They make things even for the car. The materials they can make it in it's second to none. So it's become now a very important part of designing a car. But as I say, it's now moving on to the fact that you can actually make car parts with it as well. As I say, a lot of parts of the brake ducts would be made in it. Some little flick-ups here and there, all sorts of stuff. So yeah, it's now become an integral part of the design of a car.
It's amazing, really, because if you go around an F1 factory now, you're very used to the sight of all the CNC machines making all sorts of stuff, and they're great fun to watch now. But increasingly, you'll see these big banks of 3D printing, of additive manufacturing technologies that are being used, and both for polymer-based stuff and for metal-based stuff. So it's become a really big thing now. You have to have pretty heavy investment in multiple machines in that now if you're going to have a modern F1 team.
Yeah, no, it is very important. To say this company I use over in Colnbrook now, the machines they've got is incredible. The variation in size, but also materials it's endless. And I suppose it's one of those sort of things. You can, for the wind tunnel model especially, you can find a new front wing end plate solution or a gizmo here, a gizmo there, and you model it, press a button, and you have it by tomorrow morning. It's there, it's ready to go. It's not as though you need to start and machine it and paint it or do anything to it. It's just, it can happen. And it's, the structurally they're very, very sound. And so it's one of those sort of things where, as you say, it's now become just, it has to happen. Most of the teams now will have a lot of the machines themselves, because nothing like having it in house. So I don't know how many machines that a big team would have, but you'd be talking 5, 10 of these printing machines, to be honest, just because they can. That's why not. And you make multiple parts on it overnight. Just whatever size your bed is on that machine, if it's a metre square, you can fill it full of parts and have them spit them out tomorrow morning.
Yeah, you get these these sort of big printed sections where they're mounted on sort of a base plate, aren't they? So you have multiple different parts. It's not just making one thing at a time. So yeah, like you say, it's almost like a little Tamiya model kitter, isn't it? Something you sort of pop out all the bits. Not quite that simple, but it's it's a very efficient way of doing it in that regard as well.
Talking about Tamiya models, I was up in the roof of my garage. I've got a Tamiya model of a Lotus 72 and of a Brabham BT42, I think it is, from back in the day, and still in the box, untouched. It's just funny the things you find when you go in the roof of your garage.
Yeah, it's going to be one of your. Was that going to be one of your build projects then, or?
It was, yeah. It never happened. I might have to pass it on to the grandkids, but yeah. But
we'll have to get you a Jordan 1911 because there was definitely a Jordan 191 Tamiya kit. I may have even done one back in my younger days, although it won't surprise you to know I wasn't especially adept at making them because I'm more deal in the world of theory than practicality.
Yes. No, I always enjoyed building those sort of things, but I think as you get older, the old hands get a bit more shaky, so you need to pass it on. My grandson, he's Jacob. He's mad about it. He just builds things like that. It's amazing. He's so good at it.
Yeah, you've shown me some photos of some of the stuff he builds. It looks very much adept. There's definitely some of the old Anderson heritage passed down there. But yeah, I think it is interesting, and we'll hear in the interview in a bit how much 3D printing has been used. Does it surprise you that this has happened so much, or would if you of 30 years ago said, "Oh yeah, in a few decades, this is going to be a big deal. It's not just going to be prototyping parts; it's going to be making parts that are on the car." Or has it surprised you just how far it's moved?
I don't think it surprised me, no, because once that sort of thing gets momentum, it just keeps on going. So it's about anything like that. You just have to get it in the door to begin with, and then all these engineers in F1 or aerospace or whatever, that use it will ask questions of the companies about using different materials or doing it a different way or, making it faster, making it stronger, whatever. So, you know that it will just improve. And that's what it's done, really. It has improved dramatically over the years. So it is just, as I say, time stands still for no man. And that's a typical example of it. Something new comes in and then suddenly 20, 30 years later, you have to have it. It's there. It's part of it. It's like 5-axis machining. There was a time whenever you would get the hacksaw out and, cut something up and file the end of it and, make it. Now you have to press the button and so it spits out this super complicated, machining. So yeah, technology just moves on constantly.
Yeah, it's amazing the shapes that can be created, the elaborateness in all sorts of materials with all sorts of different methods. But I think everyone will enjoy hearing the interview in a moment. Well, it's time now for our interview, which is with Matt Jones, who is Senior Application Engineer for Stratasys. Stratasys is a specialist in 3D printing and additive manufacturing. It supplies equipment, materials and software, as well as printing on-demand services, and it's been a pioneering force in this technology. And in F1, it's a partner of McLaren, supplying it with 3D printing and additive manufacturing solutions, working closely with the team in a wide range of areas. It was a fascinating interview about a wide range of technologies that are often talked about, but not always fully understood. And it just shows how wide-ranging the applications of this kind of thing have become in F1 since the early days of rapid prototyping that we were talking about with Gary. I'm delighted to be joined by Matt Jones, Senior Application Engineer from Stratasys. Thanks very much for taking the time to talk about 3D printing technology and its F1 applications. So Matt, perhaps as a starting point, you could quickly tell us about your role and Stratasys.
Yeah, so I'm Matt Jones as an application engineer. I've been in 3D printing or additive manufacturing for around about 18 years. So Stratasys is one of the leaders of polymer 3D printing or additive manufacturing. We don't focus on metals, just polymer. And one of our key areas is the F1 industry. It's one of the biggest and one of the earliest adopters of 3D printing technologies out there.
Yeah, I was going to say 18 years in this kind of technology. That's right in the sweet spot, isn't it? Because it's come on so much in that time. I guess it must have changed vastly in almost 2 decades.
It has. I wasn't really aware that 3D printing was there and that it's been around for well over 30 years. A lot of people think that it's only a relatively new technology, but it's a well tried and proven technology that's been used by many different industry sectors. So yeah, it's a good one to be in.
So let's get into the basics of it. I think everyone listening will have some degree of familiarity with 3D printing, but there's a lot of terminology thrown around: 3D printing, rapid prototyping, additive manufacturing. Can you give us the 3D printing 101 as a starting point? What exactly are we talking about?
So in the case of Stratasys, as I mentioned earlier, it's a polymer system. So that's where we're using plastics. We have 5 core technologies at Stratasys. And as you say, there's a lot of acronyms and things that go with it. But in essence, we have stereolithography, which is a top-down system where we have a laser that fires into a vat of resin that's cured by UV light. So it has photochemicals in there that react with the wavelength of the laser that's been shot in. And then basically from the CAD or the design that you've done, your computer-aided design, it builds it up layer by layer. So that one's used in all industries as well. Then we've got Polyjet. Polyjet is the best way to describe it, I guess, is an inkjet printer like you have at home. But instead of ink, we're using, again, a photopolymer resin, and we've got a head that simultaneously deposits that material and cures it with a UV light at the same time. And there's a couple of different processes within that one. That one allows you to do sort of full model realism. So full color, you can do elastomeric material, so rubber-like ones with different shore hardnesses. You can take any graphical design that you may have come up with and overlay that over the top of the part, so you can actually print text graphics as they were shown on your computer. Then there's DLP, which stands for digital light projection. That's a bottom-up approach where you have a DLP projector firing an entire image into a tray of resin, and it's different to stereolithography because the laser in stereolithography has to scan over and selectively cure the areas that you want, whereas DLP it fires one image in its entirety. So if you have 1 part or 10 parts on the build tray on the exposure zone, it cures it in exactly the same time, whereas stereolithography has to go and do 1, then 2, then 3, then 4. So it's slightly slower. But our machine for the P3 has real engineering grade materials or use cases for those materials compared to other ones out there. Then we've got FDM, which stands for fused deposition modeling. Best way to describe that one is it's a glorified glue gun on an XY country. So we melt and extrude beads of real engineering grade thermoplastics, whether that's carbon fiber filled materials, whether it's PEC based materials or PEEK based materials, other nylons, ABSs and things like that. Then we've got the SAF machine, the H350. This is our powder-based system where we use powder that has a selection absorption fluid that's deposited, and then we irradiate the area with infrared heat, and that solidifies or cures, in essence, that area of the powder that's been deposited. And that's really for the mass manufacturing where you want tens of thousands of parts from the machine.
And the fact there's so many different techniques and different bits of technology you've explained there, I guess will hint at how widespread the application is, because you obviously have different techniques for different kind of things. Obviously, as you said, F1 was quite an early adopter. I think 3D printing technology started to creep in late 1980s and has grown ever since. So can you give a bit of an overview of the applications and also which technologies would be used for what sort of parts?
Yeah, so nowadays they use different F1 teams use pretty much all of the technologies out there. So stereolithography, Polyjet, and FDM being the most. It started off as just prototyping for the aerodynamics. So as F1 synonymous with aerodynamics, and computer-aided design and the computational fluid dynamics, they wanted to be able to test the designs and the theories in the wind tunnel testing. So, they'd use a 60% scale model, and they can do, the different housings, the front wing, the rear wing, the entire frame of the car, brake ducting, everything. And just to see those different designs and how they work for different tracks and different conditions. So prototyping was the first step. Then it went into tooling, so jigs and fixtures for, composite layup tools or for holding different devices and items when they're assembling them or making them. Within tooling, you've got the composite layup tools. So with FDM and also the Neo range, the materials are really well suited for going into an autoclave, so high temperature resistance, high pressure resistance, good surface quality, to actually make the end-use parts and soluble cores as well, or mandrels, which is where you you wrap a 3D printed part with composite material and you wash it out or pull it out afterwards, and you're left with a composite duct. And then it moved into end use parts. So there's, as an example with McLaren, there's hundreds and hundreds of sensors all over the car, and those are actually end use parts. So it started off with look at the prototyping, then we'll look at the tooling and production, in the actual materials they wanted to use them, and then it moved on as the technologies developed and the materials have developed into end use parts.
And when it comes to end use parts, obviously the traditional thing you think of with 3D printed parts is that they're the parts that aren't suffering from too much fatigue or load or temporary parts, but it does seem there's more actually being used properly on the car. I know there's a lot in the metal side, which obviously you're not dealing with, but how about with what you're dealing with? How many parts might you see on a Formula One car that are 3D printed in origin?
It's a very good question. I can't give you the actual numbers, but there's a lot of end use parts on the cars, depending on the team and which technologies they have. So not all teams have all technologies. Some only focus on specific areas, and others have other equipment as well. So, but it could be, as I say, it could be anything. It could be the brake ducts. It could be part of the front wing. It could be the steering wheel. It could be the grips on the steering wheel that's been customized. It could be wiring harnesses. It could be sensors. It could be a plethora of different things.
Obviously, when it comes to 3D printing, people tend to think about the fact it's quite quick. That's one of the advantages. But how many advantages does it give in terms of the structures of what you're making, the shapes that you're creating? Because obviously one of the big things in Formula One cars, certainly aero-wise, has been these incredibly elaborate aero shapes that have come in over the years. So has it really driven that advancement as well, in that you can make some pretty remarkable shapes that you couldn't do with more traditional manufacturing systems?
Yeah, you're quite right. So without 3D printing, the computer-aided designs that they've come up with, they couldn't either be traditionally machined, or if they were, the lead times and the cost associated with those designs would be astronomical. And as you know, budgets are reducing per season. They don't have the same amount of money to spend that they used to have, or they don't have the same amount of time to spend in wind tunnels or on rolling roads. So having the ability to do multiple design iterations for the side pods, the entire car, the rear wing, the front wing, the drag reduction system, it's a massive, massive time saving. So as an example, you could say the entire top frame of the car, bodywork of the frame, can be printed at a 60% scale model in 3 to 4 days, and then stuck into for testing. So it's a massive advantage to see what's going on for those mid-season changes or whatever they're doing for the next design iteration of the car. But without it, it would be a much, much slower process, and you wouldn't see all of those funky designs that you see. I think some of the cars out there aerodynamically, without it, they wouldn't perform anywhere near as they do now.
And how helpful has that been for driving the technology? I guess as an F1 team partner, it won't just be you supplying services. You'll have times where people will pick up the phone and say, right, we want to do this or make this, and that isn't necessarily within the bounds of what we've got currently. How can we do it? So does that throw completely new and niche questions to you that you wouldn't otherwise be taking on, and help drive your technology offering that you can send out to the rest of the world?
Yeah, as I said earlier, I've been in the industry for 18 years, and every single day I learn something new, and that's based off the questions that are given to us by the customers. They want to push the bounds of the materials being key to drive the applications, which then obviously help a manufacturer like Stratasys look into the R&D of new technologies and new materials. People want heavier filled materials. They want more chemical resistant materials. And without, the feedback from people like the F1 teams, we wouldn't have been able to progress. And it helps us in automotive sectors, the normal commercial vehicles, in aerospace and all sorts of things as well. So for us, them being one of the key adopters of 3D printing has driven us, much further down the line. I mean, McLaren have an awful lot of machines. They have the big Neo 800s, the big Neo 450s from the SL side. They have the F900, which is our largest FDM machine. They have the Polyjet machines. They have pretty much 1, 2, 3 or 4, if not more, of everything that we sell. So yeah, it's we're very grateful.
Well, it is remarkable when you see the machinery the teams have got. I've had the privilege of seeing quite a few of these in action at various teams, which makes it a little bit easier to conceptualize what they're doing. But one of my favourites actually is the stereolithography, because it's just great fun to watch. Obviously, there's the sort of light show element to it, the fact it's dealing with that top layer. Perhaps you can explain a little more detail how that works, because it's just amazing to see these things working. Obviously, you're dealing right with the top layer and then sort of brushing it off and then cutting the next bit. Well, I say cutting, it's using light, isn't it, to harden it?
Yeah, so additive manufacturing as opposed to subtractive manufacturing. So subtractive is where we look at CNC machines, where you start off with a big billet of metal or a big lump of raw material, and you take away material to get to the shape that you want. Whereas 3D printing or additive manufacturing is we're only building what we want, where we want, within a given build envelope. So focusing on stereolithography, you have the laser above, and when that hits the resin, which is contained in a big vat, so you can build rather large parts on the machine. The initiation between the laser and the wavelength of light and the chemicals that are in the vat, they start to solidify and cure. With, as you said about the recoating, so we have a mechanism that recoats and keeps the resin level, and then it basically deposits more material down to make sure that there's no gaps or de-wetting on the top surface of the build area where we're going to cure, and it repeats the process. So it's literally taking a 3D printed design, putting it into thousands and thousands of layers, and then it scans each one of those layers and repeats the process. So it's been around for a very, very long time, along with FDM, and DLP. They're the core technologies that have been around for a long, long time. But stereolithography, with the surface finish, the accuracy, and the usability of the machine, they're very simple bits of kit to sort of get to grips with and use. But hopefully that answers that question.
No, it doesn't. One of the other things you see with a lot of this machinery is you'll see the times to completion, as it were, on it. And it shows how quick this sort of thing is, because you'll see, right, this will be done in 17 hours, 36 hours, that kind of thing. So even the biggest things seem to be kind of less than 100 hours from what I've seen anyway. Is that a fair idea of the kind of range of timescales you're working with? What's the absolute top end for that?
It's a good question. So if we looked at aerospace and the defense sector, for example, very large composite layout tools, so where you're building multiple pieces and then bolting them together, they can take in excess of a week to print those different sections. But then you'll have, a 4-meter diameter radome, for example, where you can do really large end-use components and lay up over the top. For F1 specifically, the size of parts, most things will be done within a couple of days, 2, 3, 4 days at a push. In different sectors, as I say, aerospace and defense, they can take a lot longer. It's not like where you're able to push a button and within an hour everything comes off. The technologies are improving, the speeds are getting quicker and quicker and quicker. But we're not quite at a point where you can push a button and within an hour you've got a massive part. It does take a few days to get stuff off, which is quicker than the traditional methods of machining. When you look at traditional methods of doing a composite layup tool or making a brake duct or making front wings and things, it's a lot longer. Those take weeks and weeks to build. Whereas if you can reduce that lead time and manufacturing cost down, typically on average, it's around 60 to 80% time saving. And the same goes for the cost saving as well versus traditional methods.
It's interesting you say, obviously, it does take time. It's not just kind of key it in and it's there in an hour, but that's almost the science fiction version of it, isn't it? And obviously this is a technology that's still relatively young. So what's the future for this? How far can it be progressed in terms of speed and precision and the range of things that can be made, and how might that impact F1 in the longer term?
Yeah, I think that there will always be speed improvements with a factor of X when mechanical things like the gantries are improved, the servo motors are improved, extruders for FDM are improved, or the scan speed of a laser is improved, or the photochemistry or the materials react differently or quicker. it will get to a point where, as an industry, I think the idea would be that everybody has a 3D printer at home, like you have a desktop printer. And let's say you want a new mobile phone cover and you like the design, you'll click print and it'll pop off the machine right next to you. We're not there yet by any stretch of the imagination. But in the time that I've been doing it, as you said earlier, the technology advancements that have been out there by us and other people have been massive. It's leaps and leaps and bounds that are allowing new industries and new applications to sort of sprout up all over the place. And F1, as I say, it's a hotbed of trying new things and getting into the latest technologies. And it's 3D printing, additive manufacturing is definitely helping there. I would say it's like when the Industrial Revolution happened and the CNC machines and all those machines that took away the manual labor and how speed things up. 3D printing is more of an evolution of a manufacturing process. In my opinion, it will just be like an everyday CNC machine in the future. Every company will have them, because it's just another tool in the box to help people make what they want to make.
We talked a little bit about how having a partnership with McLaren benefits a company like Stratasys, but obviously F1 as a whole has also made some moves that people might not know about to try and position itself as a place for additive manufacturing in general. I know particularly on the metal side they've done that because they changed the rules a little bit to open up the materials you could use. If you do it by additive manufacturing rather than subtractive manufacturing, you can do it. Is that the same with some of the materials you're dealing with? Do you think F1 is optimizing itself to be a research playground, for want of a better word, for this sort of technology?
I think any industry is a research playground for new technologies or adopting newer technologies. And without the feedback from industries like F1 or others, there'd be no progression and moving forward. I mean, take, for example, replacing carbon fiber parts that were made traditionally with 3D printed nylon parts that are filled with carbon fiber. I mean, the mechanical properties of the materials are nowhere near as strong as carbon fiber. But when you start sort of applying a composite methodology to FDM, for example, where we can have unidirectional material laid down, we can change infill patterns and what we call rasters and different infills. And you basically are trying to mimic how you lay up different plies. You can get really, really strong end-use parts. Now, they may not be as strong as a carbon fiber part, but they'll do the job. In this case, for F1, what they need to do for a couple of races without any issues. And you find a lot of people will wrap parts with composites, again in aerospace, defense, and F1 to give you that sort of unidirectional stiffness. So making parts fully isotropic. When you look at FDM, because of the way that it builds and it bonds layer to layer, you have different mechanical properties in X and Y, ZX to Z. So your interlayer bonding becomes key to getting usable parts off. And thankfully, Stratasys is the best in the market, I personally believe. And I would say that because I work for them, with the mechanical performance and repeatability from them. Other systems, they give you quality like injection molded plastics. So again, it's easy for them to run it through the computer and see how that design is going to work and look at the topology optimization and the FEA analysis and see the stresses, where the loading is going to occur and where the failure modes are going to occur in a part, and factor that into the design along with the material and the build process. So yeah, it's a big leap forward with the materials, and as goes to the playground of playing with stuff, yeah, it's a good place to play, and we learn a lot from them. So it's a good partnership.
And obviously, one area from some of the things you were talking about there that there can be benefits is in terms of lightweighting of parts, which is always important in racing cars, but it's been particularly an area where F1 teams have really had to push in the past few years. So is that something that's been something you've been particularly engaged in, just working out how to make certain components just lighter through the structures they're manufactured with? Is that an area that's really been focused on in recent times?
Yeah, it's a massive area, and we've been doing it for a very, very long time, not just in automotive, but in aerospace. So being able to lightweight a part but regain the structural integrity and the strength and stiffness you need is very important. And again, some of the ways that you could do it traditionally would take too long, would cost too much money, and 3D printing, additive manufacturing lends itself really well to that. So you can change the density of parts, you can change the raster angles, you can change all sorts of different things that I won't dive into, but you can get very, very strong and stiff parts, even though they're only sort of like 40% filled.
One interesting area that 3D printing does get involved in, which people might not assume, is things like crash structures, as I understand it anyway. So that, I guess they're single impact, aren't they? So they can fail when they're hit. But that I guess illustrates the versatility of this kind of thing, that it's not just the old school idea that it's just sort of flimsy parts that if you look at it, they're going to break. They're really, really sturdy, really, really optimized for directional loads and that kind of thing.
Yep, 100% correct. I mean, you could print a small part that's 1 mil thick, a cube in essence coming through, and you wouldn't be able to physically break it in your hand with some of the materials. And when you look at polymers, you'd think, it's only a plastic, surely I'll be able to snap it. But they are very, very strong. And with regards to those structures where the infill patterns actually aid and assist the impact. So you can design the infill so that when a vehicle is impacted on a specific point or from a specific angle, you can direct that load away from more sensitive equipment within a vehicle or from the actual driver themselves, whether that's with metal or with polymers.
So as well as achieving the strength, it's almost the tunability of of it. That's an interesting dimension of crash structures that I think is often not talked about. Obviously, we've talked about a lot of different applications and areas of this. Are there any other areas I've not asked about? That's always a good question, I find, because there's always a lot I don't know about it. So is there some realm of additive manufacturing and 3D printing that's perhaps not immediately obvious to people on the outside?
I would say, we talk about the jigs, the fixtures, the general prototyping and the production parts. It's other things like for the actual pit crews as well. I think the average is 2.5 seconds a pit stop or something like that. So being able to create new tools for, let's say, the guns, the shrouds, for taking the nuts off and things, or for cooling down the engine bays, all of these things that you wouldn't see when it's televised because they're painted up and they look like, traditionally manufactured parts. All of them play into the realms of making the team perform much, much better. Being able to customize the front wing or the brake ducts per race, per weather condition, it all has massive, massive effects. And then I think when you look at the way that it sort of jumps off from F1 into traditional automotive for the manufacturing, it's the same things, the gains that are made from there with aerodynamics or lightweighting or the speed of creating a 3D printed tool for assembling parts and cars quicker. It makes a big jump forward. There are lots of things that they do in F1 that I'd get shot if I said. But yeah, there's lots of other things as well. But as you know, it's confidentiality, and they like to keep things very close to their chests.
Yeah, of course, only logical. But it does show how broad the applications have become. And whenever there's new technology, there's always promise of what it could achieve. But quite often it's a process that's looking for a function in the end. And then the number of functions that you can use it for just grows almost exponentially. It feels like that's where additive manufacturing and 3D printing is, insofar as it's probably being used for far more areas, and perhaps areas that were not originally thought of, than if you were looking at what the future would be, say, 15 years ago.
Yeah, so you can print teeth. So if you need a new tooth, you can print those end use in the mouth. Hearing aids, manufacturing of shoe soles, jewelry, watches, aircraft components. So most planes that you fly nowadays, they'll have hundreds and hundreds of 3D printed parts. You won't see them, for HVAC ducting systems, all sorts of things in the avionics, but they are there in the background, and it's being adopted more and more and more, and you just don't know that they're there. In medical, so if somebody has, a tumor or a serious condition, you're able to take data from MRIs or CT scanners and actually segment that and print a skull with a tumor in, and it helps the patients. Obviously, it speeds up the diagnosis. It speeds up the time that the people are in the operation theatre, and it saves lives, which is a big thing to say, that 3D printing, it's not just F1 cars or fast jets, or in the defence realm, tanks and all sorts of things. There are applications out there where it genuinely saves lives, and also, for example, you can print an eye and pop it in if you've lost an eye. There's loads of things out there. And again, different suppliers offer different things. You can even print human tissue and grow human bone via 3D printed structures as well.
And I think that shows the benefit that something like Formula One can have, a fundamentally not futile pastime, but it's not a core human activity. But the fact that being involved in it can then have some kind of backfill almost into that sort of thing, into all sorts of applications, I guess shows why a company like yours is involved in it.
Yep. It's a great place to be, with lots and lots of requirements to get thrown at you on a day-to-day basis. And as I said, I learn something new every single day, and I've been doing it for 18 years. I'm very, very passionate about 3D printing, additive manufacturing, and also the F1 sector as well.
Well, it's been fascinating to get an insight into 3D printing in Formula One. Thanks very much, Matt Jones. And I hope the next 18 years are just as fascinating in terms of the evolution of this technology.
Appreciate it, Ed. Thank you.
You're listening to the Race F1 Tech Show, brought to you by Aramco. Aramco continuously push the limits of engineering excellence. As the global energy partner of F1, they drive a shared vision to real-world innovation that aims to lower emissions, enhance performance, and accelerate human potential. Aramco, powered by HAL.
Well, if you're listening to this podcast, you understand the value of asking questions. At Aramco, answering questions helps them engineer a better future. So if you'd like to know how something worked in F1, make sure you send us a question to answer on a future episode of this podcast. It can be on absolutely anything, F1 ancient or modern, something technical you've always wanted to know the answer to. And as I always say, there's no stupid questions. Sometimes the most simple seeming questions are the ones that produce the most fascinating answers. So no question is too simple or too complex for Gary to take on. You can send a written email to podcasts@therace.com. That's podcasts@the-race.com. Or if you prefer, record a voice note and send that to us, letting us know who you are in the recording that we will play on the show. We've got a trio of questions this week, and our first is from Andy Smith. I like this one because it's a follow-up question. I like follow-up questions because it shows people are listening. The question is, Gary was explaining in the latest podcast how pneumatic valves have replaced old-fashioned valve springs in F1 engines. Does that mean that modern engines still need or even have camshafts?
Well, yes, they do still have camshafts. That what I was saying, that it hasn't replaced it with a pneumatic valve. It's replaced it with a pneumatic cylinder, which replaces the spring. And there's pressure inside that cylinder. So basically, the camshaft is still opening and shutting, opening a valve. The air spring is then closing the valve, which is the important thing. There has been engines ran, and probably engines running with a pneumatic valve opening and closing system. So it's one of those things where it has been done, it can be done, but the regulations don't allow. You have to have a camshaft. So basically, that technology is out there somewhere. Could be used, but it's not at the moment. The air spring system is, it's quite a nice little system, to be honest, rather than the spring, because whenever you had very high revving engines, the spring would get into a sort of flutter where it would be opening and closing so quickly that it would actually sort of sit in midair and not close the valve properly. And that's really where the air spring came into play. But now the engine RPM is a bit lower, you could get away without it, but because it has been developed so well, you might as well just hang on to it. There's no reason for it, and it is a better solution at the end of the day than trying to match up all these valve springs to be the same, because the air pressure in the cylinder will be the same. So much more consistent, although you can get the odd problem with it.
Excellent follow-up there. So if you do have any questions you want to know a little bit more about, fire in a follow-up question, and we will definitely take that one on. The next question comes from Brent from LA. A slightly different kind of question here, but Brent asks, would it be practical to pursue helmet visors with augmented reality displays as a solution to wet weather driving? Using HD radar, which can see through rain, and existing telemetry as inputs, it seems like it should be possible to provide drivers with visual representations of other cars and possibly the track. It might sound far-fetched, but there are already AR products coming onto the market that share many of the traits needed by F1, such as being lightweight, low latency, and compact.
Yes, Brett. Well, it's one of those sort of things. It is available. It is there. It could be used. I think getting confidence in it is the biggest thing. Again, when using it on an airplane, it's slightly different. The reality of it is things aren't happening quite so quickly. So you've got time to sort of question it, I suppose. And if you're landing and you're using it, you're doing that sort of thing. You've either got vision or you haven't got vision. It's about landing with instruments instead of the pilot landing it. It's very similar in the fact that it's just taking inputs from something else, and you've got to rely on all those inputs happening. And I think it would take time before drivers. I know from my point of view, if I was driving, it would take time before I would get confidence in it. You still want to sort of see the crowd change, see the crowd waving or whatever, all those orange T-shirts that we see. You want to see those things rather than just be looking at a screen. So yes, I'm sure the technology would be there, and I'm sure it would work fine, but it would need to work really well. I think there's other things. My personal opinion is all these cars have got sensors on them, one thing or another. The car, you could have, we see the lights on the dash that the driver gets for his gear change and stuff. You could have an array of those lights where it's a distance system to another car in front of you. There's lots of warning systems you could give the driver rather than him having to see it, that he's getting close to another car. So it's one of those sort of situations where you could have it to the left or to the right, depending upon where the car in front of you is. It would just be another thing to tell the driver, look, if you can't see it, there is a car up there, and when that light goes from yellow through to red, it's only a car length in front of you, and at yellow it's 5 car lengths in front of you, or whatever. So there's systems that you could use, but it's about just giving the driver confidence that it's working and working consistently. And I think any heads-up display would be very similar. It need to be started to be used and tested, for a few years before anybody would try to really buy into the fact that this is real and it does work well enough to drive blindly into a black hole as such.
Yeah, it's an interesting idea, and I was thinking about how much information drivers would need because, as you pointed out there, other cars is the key one. They'd probably be able to do it with quite a small amount of information because obviously we're talking about augmented reality. So as long as they can orient themselves and know if there's other cars around, they're probably happy with that because that's the big thing. There was a good incident at Spa before the August break when Hülkenberg was battling with somebody. I think they were charging up towards Les Combes in the wet and neither of them could see. And basically they both ended up braking for the corner, then realising, we haven't actually quite got there yet. So then they get back on the power and then jump on it, and one will have gone slightly first. But it just shows how disorientated drivers can get. But it probably wouldn't need much information to be added as long as it was reliable for it to work. So I think it's a really interesting thing that should really be attacked because it seems much more likely to work than spray guards, that's for sure.
Yeah, I don't disagree at all. I'm just saying it just from a driver point of view, just trying to get confidence in it that you are driving into something and you are relying on the technology. So it would need a lot of research time and effort put into to basically take it, where it needs to get to. And on the way there, I'm just saying there could be other things on the car that could give you a warning of other cars around you. I mean, these cars we saw this weekend when I think it was Carlos Sainz came out of the pits, and he can't see the car beside him. The rear view mirrors are useless. Never mind looking forward. And it's very, very easy to, if you're parallel with another car, you don't even know it's there really, to be honest, or if somebody's halfway beside you. So it's one of those sort of situations where, you need to, I think, having this warning system that there's a car around you would be quite good. Even if the car that you're in, if you know there's another car close behind you, never mind the car in front of you, it's just one of those things you could probably take a bit more avoiding action. But as I say, I would love to see the visors being the dream thing for the just slip it on and away you go, and forget about the conditions. But it's so difficult to get confidence in that sort of thing. Initially, I think it's just really, really so difficult. Take years of running before we could, you could really sign it off.
Yeah, I'd agree 100% with that. That's a very long lead time project, but certainly one that should be had a look at, I would say. Our third and final question is in audio form, so let's hear it.
Hi, Ed and Gary. This is Joe Farron from Orlando, Florida. I'm a relatively new F1 fan, coming to the sport in early 2022. I've fallen in love with all aspects of racing and appreciate your thoughtful insight and British wit on your variety of podcasts. I was even gifted a The Race t-shirt for Christmas from my parents. You often speak of watching driver onboards after races and qualifying to better understand their driving. What specifically are you watching for, and what should I pay attention to? I've taken an interest in karting myself, and I'm looking to better understand how I drive and what to watch for in the races. Thanks for everything, you guys.
Well, we should say first, thanks, Joe, for having the t-shirt and your kind words about our output. But Gary, watching onboard cameras, what are you looking for?
Well, I'm also glad, Joe, to see that you're becoming a good F1 fan. I've been in it for 50 years now, and I'm glad that some new people joining the club, because it's, it is a fantastic sport. It's been a fantastic life to live through, and a fantastic era. These 50 years have seen so much change. So going into it, there's two different types of driver, and I'll take a sort of example of. There's a driver who allows the car to do its work, and there's a driver who is always working the car, and that's one of the things from an engineering point of view. A driver can instigate a lot of the handling, I'm not saying problems, but the handling discrepancies between one driver and another. And, that's all you can do as an engineer, is try and fix what the driver's telling you, and that's why we see, Max Verstappen and Sergio Perez, they're usually, normally a long way apart, other than whenever really Sergio has a good weekend, but he doesn't have enough of those at the moment. And again, with Fernando Alonso and Lance Stroll, same sort of thing. They're quite well apart. And that's about, driving the car you've got, or allowing the car you're driving to actually sort of do the job. And if you're always fixing the problem, if you're always correcting little things, if you're just sort of white-knuckling the car, you always end up generating some other problem. And sometimes you need to sort of back out of the car a little bit and let the car do its thing and have confidence the car will fix itself. Because these cars are always in the transient condition. You're always turning the steering wheel, the car's rolling, it's yawing, it's always on the move. So you have to allow the car to be on the move and get to the end of that movement. And the big question is, have you got confidence that it will stop moving itself, or do you have to do something about it? So if you react halfway through it, halfway through that movement, then you're generating a problem as well. And it's a bit like when we got traction control, and we had, at that time I was with Jordan, we had two drivers, Takuma Sato and Giancarlo Fisichella. And Takuma had never really driven a Formula 1 car without traction control. So he would just come off the corner and stomp throttle flat out and allow the traction control to do its job. Whereas Giancarlo had driven without traction control, so he would actually reacting to the traction as fast as, if not faster than, the traction control could react to it. So what he was doing was confusing the system, because the traction would be dropping away because he'd be lifting the throttle at the same time as the system was just recognizing that it was going to get a little bit of wheel spin, whereas Takuma didn't confuse the system. So that's what I look for in the cars, is to see if a driver is letting the car do the work, or if he's making the car do all the work on the onboards. Just see the steering wheel action. If the steering wheel is always on the move, then the driver's reacting to lots and lots of things that's going on. But if he's nice and lazy with the steering wheel, it normally points to the fact he's got confidence that the car will fix its own problems.
Yeah, some good guidelines there. If I had in my thoughts, I'll always look as well for, obviously the nature of the steering input's important, the consistency and the precision of the driver. How they hit curbs is always really interesting, how consistent they are, because, a few millimeters on the way you hit an apex curb can make a huge amount of difference in terms of how the car reacts, how then the car does react to the curbs when you hit them correctly. The throttle application's interesting as well. If you watch Charles Leclerc, say, on a late in a qualifying lap when the rear tyres are overheating, and you see that incredible ability he's got to traction sense and just squeeze all the grip out of the rear as he can. That's something that Carlos Sainz struggles with quite a bit, and often you'll see that's the difference between them on a qualifying lap, that Leclerc might have got that. So it's trying to see all those little details. And I think the other thing I'd say is also being quite careful, because sometimes you'll see something, like you might look at an onboard at first glance and you think, oh, there's a car that's understeering. Then you've got to ask, oh, actually, is that car inherently understeering, or has it got an unstable rear? So is the driver having to be conservative to do it? So it's trying to avoid tricking yourself as well. So you also have to think, okay, right, I've seen that. Is that first order, or is that a consequence of something else? And you always need to use it with other things. You see what drivers talk about, watching cars trackside, watching the trackside cameras can be quite useful. You lose a lot of detail from those, I would say, but all of these things help you to kind of triangulate. So it's all about those details. And of course, comparing teammates is quite telling as well in terms of that style.
Yeah, teammates are very important. As you say there about, watching the car and trying to understand whether it's got understeer, oversteer. A lot of drivers, if they have a nervous rear end on corner entry, or it's not even corner entry, it's just when you get off the brake pad and turn the steering wheel, they'll just turn in that little bit earlier. And then when the car gets to mid corner, it will understeer. And as you say, the problem really isn't that it's got understeer, it's just the fact they haven't got confidence in the rear to be aggressive enough with the steering wheel to get most of the car rotation done early in the corner, and you're ploughing the front end mid corner whenever it doesn't want to know about it really. So lots of things you can learn about it, but it is difficult if you're looking at something, because there's a reason for everything. And as I say, I've always felt that drivers that were very, very reactive to the steering wheel, constantly on the move all the time, were always drivers that were sort of, I call it white knuckling it. They've always got a very tight grip on the steering wheel. They're always just ready for everything, as opposed to having a fingertip grip on the steering wheel, which just allows you to be a bit more casual about it all. So yeah, lots and lots to learn from just looking at stuff again and again.
And it's also one of those things that the more you do, the better it is, because you kind of build up this data bank, if you like, which does help. But actually, one thing you did mention there about the rotation of the car, that's also quite a good thing, particularly to compare with teammates, because it is all about rotating the car through the corner. And there's a great example a few years ago with Norris and Ricciardo at McLaren. And the way Ricciardo was driving, because he didn't have the confidence in the car, he was under-rotated. So you could take a corner like, say, turn 4 at Austria, and you could compare the two of them. And if they were overlaid, it was so clear. Ricciardo was in the corner for longer. So he was traction limited at the exit, while Norris is already out the corner because Ricciardo was under-rotated. Norris had the car rotated. So trying to compare the car in those various phases of the corner is another interesting thing to do. And there's other things you can watch about the ride and the way the suspension reacts, the way it dives into corners. There's so much detail there. You can get lots and lots of guidelines that just give you a few hints about what's happening to build up the picture of the car.
Yeah, I mean, you're talking about that. One of the things about a driver that, we talk about carrying speed through the corner as opposed to being a stop-and-go driver. If you're a stop-and-go driver, you arrive at the corner, you stand on the brakes very late, you turn the car aggressively, and you get back on the throttle, and away you go. And then you get the other driver who likes to blend the car into the corner, keep the speed up that little bit. So his minimum corner speed might be a fraction higher, but his actual lateral force is on the car for longer. The corner is a longer corner. Not only is that not helping the tyres, because you're loading the tyres for longer in the middle of the corner, but it also means you need a better balance, because the car needs to be balanced for longer to get around one given corner. So it's about 2 or 3 things. As a driver, do you get to be the latest and greatest braker, and then very quick turn the car, get it rotated, and get back on the throttle, or do you let the car carry flow through the corner? And I mean, it's something like Formula 3. Formula 3, because of the lack of power in the old days, you used to have corner speed. Whereas the more power you get, the more it's about stopping as late as possible and getting back on the power as quickly as possible. So it depends on what car you're driving and that sort of stuff. But yeah, you just got to analyse all that and see what what suits the car you're driving best.
Yeah, another thing you can do as well is try and look at some of the people who publish the data, the telemetry data, that you can cross-reference with that as well, which is useful. Follow someone like Brake on Twitter, which is at Brake with 3 R's, I think, who used to be a performance engineer for Max Verstappen with Red Bull, so he knows what he's talking about. So there's all sorts of ways you can enhance your understanding and enjoyment by looking at this. And you mentioned that you're karting yourself, and it certainly will help. I must admit, from the amount I've done about driving technique and that kind of thing while covering F1, mostly since my fairly mediocre amateur club racing career ended, there's a lot of things I think, I wish I'd known that then, because then I could have tried to apply it. And of course, I can convince myself that if I knew all that now, I'd have been winning constantly. And so, you can build your own ideal racing career that way. But no, it's endlessly interesting. And it's great to know, Joe, that you're a new fan and that's something that you've been drawn to. Well, thanks very much to Gary. Thanks very much to everyone who sent in questions. Remember, it's podcasts@the-race.com if you'd like to send in questions for a future podcast. We'll be back in a few weeks. That'll be before the Singapore Grand Prix, I think, to talk more F1 tech. So thanks very much, everyone, and stay with us for more from Gary. You've been listening to the Race F1 Tech Show, brought to you by Aramco. Be sure to like, follow or subscribe on your favourite podcast app so you never miss an episode.